Hello, everyone. My name is Shweta Srivastav, and I am a software engineer leading the OAI 5G development and testing effort for power platforms at Northeastern University. My presentation today will focus on OpenAirIX-Labs, which is a new initiative to help accelerate the adoption of OAI in North America and the testing and CI efforts we are undertaking as part of it. So OpenAirIX-Labs is basically a lab ecosystem incubated within the Institute for Wireless Internet of Things, a wireless research group here at Northeastern University. OAX-Labs is also part of the POWER program, which is a public-private partnership to deploy and maintain large-scale wireless testbeds in the US. OAX-Labs is funded by the National Science Foundation and the US Department of Defense. It is also supported by the OpenAirInterface Software Alliance as the official North American designate affiliate development partner. OAX is an active participant in several open source ecosystems, including OpenAirInterface and also Magma, Open Networking Foundation, Telecom Infra Project, and ORAN Alliance. OAX is joined in its mission by several industry and academic partners that are listed here. The goal of OpenAirIX-Labs is to serve as the North American home for development, testing, and integration of OpenAirInterface 5G standalone protocol stack. OAX aims to promote OAI as a benchmark end-to-end 5G standalone reference architecture for research and innovation in the 5G arena. We plan to achieve this by serving as a central point of contact for OAI testing and evaluation status across member lab partners and make the OAI 5G development and test status readily available for the 5G research community. In addition to performing tests on multiple test platforms, we have also set up a continuous integration or CI framework for OAI locally here at Northeastern. This, we believe, will be a significant step towards promoting a stable and compliant and performant OAI 5G stack. So the test platforms over which we have been testing OAI here include two large-scale testbeds housed at Northeastern University. First is Colosseum, which is part of the POWER program. Colosseum is a large-scale wireless testbed with 128 Intel Xeon-based computational servers, each connected to an X310 USRP. Colosseum uses a massive channel emulator that can emulate complex wireless scenarios. Arena is another in-house testbed with Intel Xeon servers, X310 and N310 USRPs, and a 64 antenna grid to perform transmissions over the air. In addition to the testbeds at Northeastern, we are closely working with the POWER AirPod teams to conduct testing on two separate test benches, one at North Carolina State University and the other at Mississippi State University. The test bench at NCSU includes a Keysight PropSim channel emulator to emulate complex channel conditions. It also includes a COTS UE module by Quectel, and hence enables us to run tests with SDR-based OAI UE as well as with COTS UE. The MSU test bench uses B205 mini SDRs and performs transmissions over the air. I would like to acknowledge all the team members at NCSU and MSU in their efforts on OAI testing. In addition to these, there are parallel testing efforts being conducted by several of our partners listed earlier, including the POWER team at Utah. An important part of our effort to get a good compliant stack is setting up of a CI system for OAI, as I mentioned before. The framework is inspired by Eurocom's CI framework and mirrors their setup to a large extent. Once completed, this will be integrated with Eurocom's GitLab code base, and any merge request or merges to the develop branch. In addition to triggering CI at Eurocom servers, will also trigger the OAX CI. In the initial setup, the CI uses Colosseum testbed as the test platform to run OAI. However, this framework is easily extensible to other Power Platforms owing to the cloud-native model of deployment. Power Platforms make use of software containers, LXC or Docker, to deploy software for experiments. We have deployed an Ansible-based toolchain, which was developed by Xylenium Research to completely automate the process of building an OAI container, which can then be easily deployed on any Power Platform. This would allow testing at scale by enabling these OAI containers to be tested on multiple platforms. This slide shows the OAI CI architecture. Looking at the high-level blocks, first, this is the Eurocom GitLab repository. The orange block here is our Jenkins server. It runs here as an AWS instance, but closely resembles Eurocom's Jenkins configuration. This blue block is what we refer to as the CI server. This also runs as an AWS instance and is responsible for building OAI containers, deploying them on Colosseum testbed, and starting the tests. Colosseum testbed is this big dotted block to the right. There will be an additional server for simulator builds and run, shown as server 1 here at the bottom. So a merge request to the OAI GitLab repository will initiate a master job at the Jenkins server. The master job is responsible for triggering the guidelines check and simulator builds and runs on server 1, shown at the bottom again. And the master job also triggers a secondary job, which initiates the Ansible pipeline on the CI server. As I mentioned before, the Ansible pipeline completely automates the process of building an OAI container, deploying the container on Colosseum, and initiating a Colosseum batch job using a configuration file. Colosseum runs the complete test based on the batch job configuration and makes the log files available in a NAS storage at the end of the run. We have also deployed an Airflow toolchain. This automatically retrieves the log files from Colosseum NAS storage to the CI server once the log files are available. The CI scripts on the CI server will parse and check test status and make the results available to the developers via GitLab in the same fashion as it is done in Eurocom CI currently. So addition of the CI would be seamless for OAI developers. The current status of CI development is that we have the basic framework or skeleton, so to say, in place for triggering CI on Colosseum, which includes the Jenkins server with master and secondary jobs, the CI server with Ansible and Airflow tool chains, running of test on Colosseum, and retrieval of log files. The next steps here are to define the precise test scenarios and configuration, definition of test cases to be validated, and parsing of log files for success or failure of the test cases. We expect the CI development and integration to be completed by Q3 of 2021. Well, if you would like to know more or would like to keep updated on the CI status or OAI test status over Power Platforms and any other developments, please check out our OpenAirInterface website listed here. Thank you.